Okay, this is a review of a GitHub ticket which was open, and it's still open. It says measure transformers backend startup time versus native. And so what that means is you have to start vllm on. Actually, you don't need a GPU. We'll find that out later. You just need a CPU. It also turns out that you can run some of the models on a Colab high RAM CPU without a GPU for debugging. If you don't care about serving fast tokens, then that works. And that wasn't there before. Okay, so the first issue is getting vllm to run in Colab. So how do we do that, and what are some of the sticky points? Okay, so one sticky point is the software. The bug turned out to be a recursive call into using the command trace, trace, parentheses module, close parentheses, and the word trace, it unleashes a profiler. And so this is the FX trace subsystem in vllm. It's a graph-based subsystem, and what he does is he builds an AST of the transformer backend, and then he substitutes certain classes with a CUDA kernel. And that only happens with transformers. vllm doesn't do that. And so there's two backends. There's a transformer backend and a vllm backend. It used to be, and I think it's still true, vllm is always faster. That backend is always faster than transformers. Now, the transformers guy says that he's just as fast as not faster, but that's just, I don't know if that's really true. And he has some measurements to back it up, but it's not worth wasting time there. Okay, the first issue, when you're replicating this bug, you can't replicate it anymore given the current distribution because the code was updated on the 20th of August and you can no longer see it. So the best thing to do is go back to a distribution prior to 27, go to 27, prior to 27.1, go to 27.0, and just search for the trace module in the file rmsnorm.py. And if that is true, then that means you can replicate the bug and you can profile it and do all that good stuff. So what's the process for installing vllm first before we get to profiling? So you have to update the OS first, and then you have to install. Do we have to do anything actually? Let me think about this. I think you have to like figure out which version of CUDA that you're running. And I don't know how did we install vllm? Because it's a little bit tricky. Oh, just install vllm. No, didn't do that here. Oh, did we do the wheel? So did he install through pip or did he download a wheel? So there are these pre-built wheels that are like a CPU wheel or a GPU wheel, and those are a lot faster than getting them to do a pip install. Pip install has to download and build. The wheel, you don't have to do that. So always go for the wheel if you can. WHL file. Did we do the wheel here, or did we not have enough experience to do that yet? Okay, so it's not clear how vllm was installed. Oh, here. Pip installed vllm 27.0. Okay, so that's the older version to make sure we get the bug. Oh, here's the wheel. So we did. We downloaded a wheel. It's CPU only. Index strategy. I don't remember what I talked about. Okay, that's great. So this is faster. That's why this is so fast. Download the wheel, and then when you run vllm, what was this? Okay, snapshot download. This is faster than doing a download by using auto tokenizer and auto model. Auto tokenizer and auto model, oh my god, they're slow. Okay, so what else do we need? So I think Flash was disabled, and I don't remember. Flash attention was disabled and removed, so we have to add a flag here. I don't remember what the other flag was for. Use PySpy. Record in speed scope format. You have the option of choosing speed scope or flame graphs. And I chose speed scope because it has search functionality where maybe flame graphs have it, but I found flame graphs harder to use. And we'll get into where speed scope is. That's a good program. That's written in TypeScript. That whoever did that really knows what they're doing. Okay. Model impl transformer. So that's the transformer backend. This is not the default, by the way. If the default is vllm, if it doesn't find the vllm implementation, it'll go to transformers without telling anybody. Enforce eager. This turns off torch AO. Torch AO builds CUDA graphs. Now, there was a comment in the GitHub that this would turn off FX tracing. That's not true. They're two separate mechanisms. FX tracing, which is FX graph, which is the transformers AST tree, substitutes certain modules for CUDA code. And then there's torch CUDA graphs, which builds a graph. And I think you can store that graph also. Where else? Okay, I think that covers it. I think we have enough info. Now, let's just make sure we scroll slowly so that if we need to replicate this code at any point in time, we can copy it. This code will be destroyed. I'm not going to save it. That's crazy talk. Okay. Wheel, download the wheels. Now, Goin, Goin, he has some web app that searches for all the wheels. I didn't really find that effective, and so I deleted that. It's a lot of overhead. So you can find the wheels from the vllm distributions. What else? Snapshot download, we know. PySpy, we know. And always tests to make sure you have the right version. Okay, I think this can be deleted and we'll have enough intelligence to be able to replicate it. Okay, that's the first issue. The second issue is PySpy. So PySpy, there's a trick here. Now when he starts via LLM, it starts a whole bunch of CPU threads. It also starts a whole bunch of GPU threads, but at first it's starting a whole bunch of CPU threads here. If you just leave it on the default and you search for the performance bug, you won't find it. What you have to do is find the longest thread. This is 45 seconds. Click on that, and you'll find recursive replace. It's the recursive replace when he's traversing the AST tree that causes delay, and that's why this thread is so long. The other threads don't show that, so it's a little tricky. Nobody really talks about that, but when you're doing performance debugging, you have to look at, you have to look at all the threads, and it's not really clear on this where it is. Now, I don't know with flame graphs how you pick that, how you display all the different threads. Maybe it does that, but I didn't spend that much time with flame graphs. What else with PySpy? These are all the kernel code. These little short instructions. I don't think they've moved over to the GPU yet. What else? Here's a big trace up here. Shift plus, shift minus, same thing like all the other profilers. Do I have enough so I can delete this and I can come to this and replicate it if I get stuck? I hope so. Okay, so we covered PySpy. We covered, here's the part where he does the recursive replace. This is the statement here. This is 27.0, not 27.1, which has been fixed. But 27.0, he calls this and it does a recursive replace. And there's no garbage collection leak. There's no memory leak because he disposes of it when the whole tree goes away. But it does slow things down. What else? This is the Vercel app of speed scope. Not a big deal. And this is the ticket. Oh, this is good. So somebody else found it. Recursive replace. This is true in base.py. Get fuser to cause those two classes work together. Here's the guy that fixed it. Blah blah blah. There's a lot of confusion here between the two between the two mechanisms, torch AO and FX graph. It's not all accurate. Okay, is that good? I think that's good. I think we're good. I think he's going to leave this open for infinity. But we're going to move on. We're going to go work on other tickets. Okay, thank you, and adios.